Yes, are you there, Marin?
Yeah.
All right. So we are doing paper to May 2024. All right. So the photograph shows infrared heating lamps being used to harden fresh paint on the car, uh, give a harmful effect of infrared waves. Yes, what could be the harmful effect of infrared waves? Yeah, Marin,
And it can cause skin burns.
the skin burn. Okay, right. Can you also say the eye burning or skin tissue burning, right? Okay. What about this question? The heating lamps produce visible light waves in addition to infrared waves. Give two similar properties of visible light waves and infrared waves. So similar properties of visible light waves and infrared waves. One of the property is very common that they both belong to what type of waves? They are
Transverse.
okay. They are electromagnetic, right? Electromagnetic waves, right? And what we know about the waves that they transfer the energy. Yes, they both transfer energy, right? The waves transfer energy. All waves transfer energy. Waves transfer energy, right?
Uh, Sir, can you give me 1 minute? I'll just write this down.
Yeah, I'll send this paper to you, okay? Give two differences between the properties of visible light waves and the infrared waves. The basic difference is that do both have the different frequencies? Yes, and the wavelength. Yes, give two differences between properties of visible light and uh, infrared waves. Differences. Infrared red waves have longer wavelength. Infrared waves have low frequency. Frequency then will be light. Okay. Uh, Marine, I think you said transfer waves over here. Yes, they are transfer waves as well. Okay. They both are transfer waves as well. Okay. Right. And even we can also write they both travel with the same speed. Okay, they both travel with the same speed, which is speed of light. Okay, in vacuum, right? The infrared heating lamps are placed 1.5 meter from the car. The distance is given. Calculate time taken for infrared waves emitted from a lamp to reach the car. So we have to find out the time. And for infrared waves, the speed is given, which is 3 into 10 to the power 8 meter per second. So how can we find the time? What we know about the wave speed, that it is 3.0 into 10 to the power 8 meter per second, and the distance is 1.5 meter from the car, and that we have to find out the time. So since we know S equals to VT, so we will divide the S by V. Okay. So T equals to, substitute the values, 1.5 by 3.0 into 10 to the power 8. So what will be the answer? Is it going to be 0.5? 0.5 into 10 to the power minus 8 seconds, right?
Sir, how did you guys did you put this in the calculator?
Yeah, you can put into the calculator, okay?
Okay.
And tell me the answer. What answer are you getting?
Sir, I think it would be -9, not -8.
No, see what I have done. Let me tell you. 1.5 times 1 is 1.5. 1.5 times 2 is 3, right? So 1 by 2 is going to be 0.5, okay? And then I have flipped this 10 to the power 8. So it becomes 10 to the power minus 8. So I have done without the calculator. You people can get the value with the calculator, and you can also get it 5 times 10 to the power minus 9, okay?
Yeah.
5 times 10 to the power minus 9. Marine, is this clear to you as well? Either you can write 5
Yeah.
times 10 to the power minus 9, or you can also write 0.5 into 10 to the power minus 8, right? That's the same thing. Okay, paint takes less time to harden when it absorbs more energy from infrared radiation. A technician observes that white paint takes more time to harden than black paint. So they are comparing white paint and black paint. Yes, if you people recall the concept of the good absorbers and the uh, good emitters or bad absorbers.
Darker
Yeah,
colors emit more radiation.
okay. Yes, Mary, what do you think? What should
And they
be?
absorb, dark colors absorb more heat, so that's
Yeah, exactly.
would
So the
get
black
absorbed
is
faster.
good. So black is a good or better absorber of infrared radiation, okay? Right? So which one is taking more time? The white one, right? So how can we write the answer? White paint is bad absorber. Absorber of what? Of, either you can write heat or you can write infrared radiation, okay? Be very specific, okay? Write a very specific answer. That would be incomplete if you write white paint is a bad absorber. Bad absorber of what? You have to mention it, okay? Infrared radiation. White paint is a bad absorber of infrared radiation, and whereas black is better, or we can say good absorber of infrared radiation. Okay, so more energy is absorbed uh, by the black by the black uh, paint, right? Even you can also write in lesson, okay? In right now, this is also not included in our syllabus right now. Okay. Now here we have the question related to Hooke's law. Metal spring obeys Hooke's law. Sketch a graph to show that a spring obeys Hooke's law as it is stretched. You should label both axes with the appropriate physical quantities. All right, so if you recall Hooke's law, in Hooke's law, we always talk about proportionality, right? And if the two things are proportional to each other, right? So it should start from zero, right? So how can we sketch the graph? Any idea how can we sketch?
On the y-axis, we can take the force,
Okay,
and on the x-axis, we can take the length, yeah, extension.
okay, all right. So
Extension is
that
directly proportional. The extension
okay,
is directly proportional to the weight added.
okay, all right. Yes, Marine, what do you think? Extension is directly
It's
proportional
gonna
to
be a
force?
straight diagonal line.
Excellent. And it should start from
The origin.
origin. But okay. So yes, you people are right. It should start from diagonal. It should start from origin. And we have to mention extension, right? And over here, you can write force or weight. Okay.
Sure, the 3 marks is for one drawing the line, one labeling the y-axis, and one labeling the x-axis.
No, one is for labeling, and one is for the straight line, and one is for starting from origin.
Oh, okay.
Diagram 1 shows an object suspended from a support using a metal spring. The object is initially at rest. The object is pulled down and then released. Okay. The diagram 2 shows the forces acting on the object at the instant it is released. Uh, okay. The force diagram is given, right, in diagram 2. Determine the magnitude and direction of the resultant force acting on the object. So since the two of forces are acting in the opposite direction, right? So we can subtract them, right? So 3.2 minus 2.0 will be 1.2, right? So 1.2 Newton, and direction of resultant force is upward, right? Okay, is along the direction of the greater force, right? Is this clear?
Yeah.
All right, so the object has a mass of 0.20 kilogram. Calculate the acceleration of the object at the instant it is released. So the mass of the object is 0.20, and the resultant force, the instant force when it is released. Diagram 2 show the forces acting on the object at the instant it is released, right? So what is the resultant force that we are having on this object? That is 1.2 Newton. Okay. So uh 0.20 kilogram, right? And we have to find out acceleration. What is the resultant force? Resultant force was 1.2 Newton, right? Okay. Now, if you recall F equals to ma, So we can
Where will this formula be given?
yeah, this formula will be given to you, okay? In every paper, the formulas will be given to you, okay? Right?
Okay.
So equation of motions will not be given to you. Number one and number two is no, the equation of motion will be given to you, but this few formulas will not be the part of that. All right, so we have to make A subject. So F divided by M, it will be 1.2 divided by 0.20. Okay. So what should be the answer? Yes, please. Yes, come on. 1.2 divided by 0.20. What should be the answer? Anyone please tell me. It will be 6.0 meter per second, right? Meter per second square. Done. Explain how the magnitude of the acceleration of the object changes from the instant the object is released until the first time the object returns to its initial resting position. Explain how the magnitude of acceleration of the object changes. Yes. Let's recall the concept of acceleration, how the acceleration is produced. Acceleration is directly proportional to the resultant force. Yes. Okay. If the force is, if the resultant force is there, the acceleration uh, will constantly be produced, right? Okay, from the instant we have 1.2 Newton force, okay, when it is released until the first time, and the object returns to its or initial position, resting position. That means the 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 spring is going to lose the energy, right? Okay, so what do you think? Initially, the acceleration will be greater and then gradually it decreases. Yeah. And ultimately the spring extension would also decrease. Yeah. So initially the resultant force is greater. Okay. Acceleration will be maximum, right? And then gradually uh acceleration decreases. Am I audible? Hello? Gradually acceleration decreases. Hello,
Yeah.
am I audible? Okay. Gradually acceleration decreases, and then uh what will happen when the spring gets stretched and
It'll go back
it
to its
it
it'll go
it,
back to its
it, it
original position.
yeah, initial resting position. That means the extension is decreasing every time the extension is decreasing. Okay, so extension of a spring, right? Extension of the spring decreases, right? Any confusion here? So that
No.
means which means that force from 1.2 is going to be decreased, right? Force from 1.2 Newton decreases. Clear? This is actually the cause of uh, of decrement in the spring extension. Okay.
Okay.
And what do you think? Weight of the object becomes same or different? Will the mass of the object would be different or same? Okay, so let me write it here. Weight will be same, thus forces becomes balanced, right? Forces become balanced. That means this is the object. Okay, so the force that is coming, that is in the form of tension. Okay, and the force which is in the form of the weight. Okay, they both become balanced. Is this clear? So there will be no resultant force. Is this clear? Right? Marine, is this clear to you?
Yeah.
Resultant force, eventually resultant force will become zero. Why? Because the upward force and the downward force both become equal. Okay. I hope this explanation is clear to you guys. Magnetic field lines near the south pole of the bar. Okay, so we started this topic, but due to the exams, we have stopped. So this topic is not being assessed right now. Okay, in upcoming assessment, inshallah, we'll continue with this topic. Now, electricity. Here's a question of electricity. The diagram shows a domestic lighting circuit, right? Where the main supply is 230 volts. Okay. And the three lamps are connected in parallel. The three lamps are connected in parallel, right? Okay. And each lamp is having a separate switch. Okay. Right. And you people know that in parallel, what divides, and in series, what remains same? Yes. In
Current.
parallel, oh, okay. So in parallel circuit, what divides?
Current.
Current divides. Okay. Marine, what do you think? In parallel circuit, what divides?
The current.
Current divides. Okay. And in series, the current remains same, right? Okay. So explain an advantage of using this circuit for domestic lighting. Yeah. So advantage, since it's a parallel circuit, so each lamp can be, can be controlled, can be operated separately, right? Yes. Are you
Yeah.
getting this? So lamps can be controlled independently or separately. Okay. Lamps in parallel circuit can be controlled separately or independently. Okay. Any other advantage do you think that we can include? Yeah. What could be another advantage? Since it's a parallel circuit, so if one lamp becomes faulty, other won't get affected. Okay. Right? Clear? Hello, guys. If it is clear, so that we can move on.
It's
Uh,
clear.
okay. Marine, any question? Do you have any question you want to ask?
No, it's
No?
clear.
All right. So when switch 1 is closed, the current in lamp 1 is 22 milliamps, right? When switch 1 is closed, the current in lamp 1 is 22 milliampere. Okay, when this switch is closed, the current that is flowing through Lamp 1 is 22 milliampere. Give the name of the charged particle that moves in an electric current. Oh, wow. Charged particle. What is the charged particle that moves in the wire? Yeah, what is the name of that particle that moves in the wire? And it's a charged particle, right? It's a charged particle. Yes, guys.
Electrons.
Electrons, right? Good. Okay. Show that lamp 1 has a power of about 5 watt. Show that lamp 1 has a power of about 5 watt. That means lamp 1, the current is known to us. Okay. So what is known? What is given for lamp 1? The current. Current is denoted by capital I. Oh, sorry. I wanted to write. Yes. So 22 milliampere, right? Milliampere, which is equal to 22 into 10 to the power minus 3 amps, right? Okay. And give uh okay, we have to find out power, right? We have to show power equals to 5 watt. Do we know the voltage? Yeah. Since it's a parallel socket, so the mains voltages will be same to each lamp, right? Because each lamp is directly connected to the main supply, okay? Right? So uh yeah. So 230 volts will be, will be there on lamp 1 as well, right? So we also know the voltages, so 230 volts. Yeah. Now we can apply the formula of power. Power equals to product of for current and voltage. So V is 230 times current, 22 into 10 to the power minus 3, right? So what is the power now? 230 times 22 times 10 to the power minus 3. Quickly. Hello. Hello. Tell me the answer. Hello. You people
1 minute,
should
I'll get
carry
a
the.
calculator.
My God, you should carry the calculator, boys. Yeah, Marine, if you can please tell me
That's
the answer.
252.001.
252.001.
Yes.
Uh, Nick, are you sure? We have to get.
5.06.
Yeah. We should get this. Okay. Uh,
Sir, can you give me 1 minute? I'll just write down the working.
5.06. Marine,
Yes,
are you also getting 5.06 watt? So our answer is correct. That is about 5 watt. Okay. Now calculate the energy transferred by lamp 1 when it is on for 30 seconds.
Sir, can you go for 1 minute? I'll just write down the
Okay, all right.
steps.
Right. Yes. So energy transferred, we are talking about energy transfer. So since we know that power equals to energy transfer over time, right? Yes, power equals to energy transfer over time. Okay. So we will multiply the power with time, okay? So we will get energy. So energy equals to power times time. Okay. So what is power here? 5.06 times time is 30 seconds, right? So 5.06 times 30. What are we getting?
151.8.
151.8 joules, right? 151.8 joules. Clear? Right? The circuit is connected to the main supply and mains voltage is 230. State what is meant by the term voltage. Yes, voltage refers to the energy, right? But it's not energy, okay? Remember. Yes, so what do you think? Voltage, what is voltage?
It pushes the charge around the circuit.
Around the circuit or across the component?
Across the components.
Across the component. So main voltage is 230. Uh, so energy transferred per unit time we have to write, okay? Voltage is actually, voltage refers the energy that transfers per unit time, okay? Energy transfers, sorry, transfer per unit time. If you recall the formula for the voltage, that is W over Q, okay? Where W is energy transfer or work done. Yeah,
Okay.
right? And where Q is the charge, right? Now switches 1 and 3 are closed, which turn on lamp 1 and 3. Switch 2 is open. So calculate the current in the main supply. All right, so uh they are saying that switch 2 is open. Switch 2 is open. So switch 2 is open, that means no current is flowing in lamp 2, only that the current that is flowing through lamp 1 and lamp 3, right? So they are saying what is the total current when the lamp 1 and lamp 3 are working, right? When lamp 1 and lamp 3 are working, so what will be the current in the main supply? Yes. Yes, guys. Since we know that current divides in the parallel circuit, so in order to get a total current, can we add them all? Yes.
Yeah.
So what should be the total current?
Switch 1 plus switch 3.
Yeah, switch 1 and switch 3, when we add these two currents, so what are we getting? 22 and 17. So when they get added, so what will be the current? 22 plus 17.
39 milliamps.
Okay. So 22 plus 17. So it will be 39 milliampere, right? Okay, clear? Is this
Yeah.
clear now? Uh, the diagram shows two waves of light A and B. Marine, are the waves coming in the exam?
Yeah.
Okay, all right. So this question is related to light and waves. So inshallah, we'll be doing it the next class, inshallah, tomorrow. Okay. And this question is related to pressure. Inshallah, we'll be completing this paper tomorrow. Okay, the rest of
Sir,
questions, inshallah. Yes, please.
wave is not coming for us.
Okay, all right. All right, fine.
Okay.
All right, so inshallah, we'll be doing the rest of questions in the next class.
Okay.